Good afternoon. In this video we'll go over an interesting and very useful model that describes some oligopolistic markets quite realistically. It is called the Kinked demand model because the demand curve looks like a bended curve. Soon you will know why. This model makes sense in situations where the environment is particularly tense. In highly tense environments, the actors tend to become overreactive, kind of nervous and jittery sometimes. When actors are tense, their moves are based less on calculated thinking and more on reflex or fear. This happens in all aspects of human behavior, especially those when something out of the ordinary transpires. For instance, during a traffic stop, most drivers would tend to become nervous, not because they have a dead body in the trunk, but because dealing with the authorities, even for trivial issues, is outside of the comfort zone. On the reverse side of the situation, the officer is also tense. This time not because the situation is unusual for them, after all it's part of their job, but because they understand that they are subject to significant risks also. So during a traffic stop, the driver is asked to remain seated in the car, with the engine off, have his or her hands on the steering wheel visible to the officer at all times, and refrain from doing any abrupt movement that may startle the officer. The last thing that the civilian wants is to send a wrong signal to the officer, like for example trying to reach under the seat or near his or her belt or something like that. Therefore, we usually observe people react with an overly cautious manner in such instances, a manner that we do not really see in everyday, usual situations. For example, when an officer in Virginia asked me for my papers during a traffic stop a few years ago, I warned him that they were in the glove compartment, I asked permission to reach, and then, with very slow moves and with my hands always visible to him, I handed him the folder of the papers very carefully. I would not do it in the same way when, say, somebody asks me for an envelope in the office. Okay, but how is this relevant to economics? In most markets, it's not, because they follow totally normal and predictable patterns. For instance, everyone expects a hotel in Santorini to lower its prices on September 1st. Everybody understands that they do it because September is not a vacation month, the weather in Greece may not be quite summery at that time, and demand for rooms decreases, so prices ought to be lower. In such markets, collusion is very easy to occur because everyone knows what to expect. In some other markets, however, pricing patterns may be really volatile. We have seen this with oil, medications, hardware, and even illegal drugs. This unpredictability tends to make behavior more aggressive, and collusion becomes not very easy. When an explicit or implicit price agreement has been established in such volatile markets, everyone understands that it's quite fragile. After all, we all know that collusion always suffers from the incentive to cheat. This means that if a price cut occurs by one of the firms, others will start becoming really nervous. Should they take this as an attempt of cheating? Should they take it as a challenge for a price war? Or is it a hint by the rival that the market conditions have changed, a signal like what we are doing so far must be revised? We have a new MR equal to MC outcome, and we must update the agreement to the new market status. Of course, the rival who cuts the price will definitely want to explain to others that has no intention for cheating, that the conditions have changed, that is always honest, especially when it comes to respecting illegal agreements of price fixing, that he swears to God that he did not mean to start a price war, and all this. The problem is that this is exactly what a cheater would also say. In strategy of negotiations, we call this cheap talk. Cheap talk is when the same exact thing that a truth teller would say, a liar would also say it. Thus, in some cases, we may have a company that understands that the cost and demand conditions in the market have changed, that it's economically suboptimal to maintain the same high price, that they are losing money by doing so, but they avoid decreasing it because they do not want to send the wrong signal to rivals and accidentally start a price war. This makes those firms to give up proper profit maximization in order to not upset the peace in the market. Kind of like when my phone fell between the car seats during that traffic stop in Virginia, but I consciously avoid reaching for it because I did not want this to happen.
Reach for it then. Don't pull it out. Don't pull it out.
So in such situations, price becomes rigid. Sellers avoid to update it. However, this behavior is one way only. If you wish to unilaterally raise the price, no one will take offense because there's no threat of undercutting there. So let's see exactly how this model works. We begin from the point where a price has already been established in this market. We do not know and we do not care how. We just know that there is a prevailing price P star. Now, tense behavior makes the demand for the firm to be kinked around P star. That is, the reaction to price changes will be asymmetrical. Above P star, the demand is relatively elastic. That is, a $1 increase in price will make you lose a large market share because most likely your rivals will not increase their prices. So you will bleed customers to them. Below P star, however, the demand is less elastic. Now, a $1 decrease in price will allow you to gain only a few customers because your rivals will follow you to the lower price and you will not grab many of their customers. Let's see how the MR curve will look with a broken demand curve. For the elastic part of the demand, the dark green one, the MR is standard, starts from the same intercept, has double the slope, and looks like this dark blue line. For the inelastic part of the demand now, the same is pretty much true, but we must extend the light green segment towards the y-axis to find the real intercept like this. Then the same intercept double the slope rule applies here too, and after Q star, the light blue MR corresponds to the light green segment of the demand. Therefore, when the demand is kinked, the MR curve is discontinuous. This discontinuity is what explains the price rigidity. Consider the marginal cost curve that led to the prevailing price we assumed initially. That is MC equals MR at point A prime, which is projected to P star through A. If now we have, say, a technological advancement in this industry that lowers the marginal cost to MC1, you should logically expect that the equilibrium price will end up being lower than P star. It will not. MR equals MC1 at A double prime, which is projected to the same price P star. In other words, the company will not take the risk upsetting the industry for a cost decrease such as MC1. They will do it only for a sufficiently larger decrease in cost such as MC2 because perhaps they consider that incorporating such a large cost improvement into their pricing is worth the risk. In principle, the Kinked demand model is not an explanation of pricing in oligopolistic environments. However, economists often use it as a description of reality since this model has so much to teach us about how real businesses behave. Write your questions down below in the comment section and I will answer. Before you add the question, check first if an answer is already there. Thanks for watching.